Department of Mathematics, Analysis, Logic and Discrete Mathematics with our special guest, Bolys Sabitbek, post-doctoral researcher at Ghent Analysis and PDE Center in Ghent University. Thank you for having us here, Bolys.
Welcome to our Ghent Analysis and PDE Center.
Before we start the conversation, could you please introduce yourself to our audience?
I'm a mathematician with research interest in partial differential equations, motivated by mathematical physics, especially from general relativity. I work in the Ghent Analysis and PDE Center, but supervised by Professor Michael Ruzhansky.
To give a little bit of a background to our listeners, actually, this episode came about when we started talking about math.
Yes.
And as an amateur or a person with an interest in math, everyone can have a different perception. But my perception was that math is the language of universe. Nevertheless, I still want to ask you, was math discovered or invented?
That's a very good question to start with. In my view, mathematics doesn't create the laws of nature. It helps to discover and describe it. For example, we can observe waves in the nature, and then we build mathematical models to understand how it behaves. So mathematics is like language that allow us to express what we observe. But same time, mathematicians also invent new concepts. A good example is imaginary numbers. It was created long before it was become useful in quantum mechanics. So I think mathematics helps to discover patterns, the laws of nature, but we invent the language, tools that help us to understand and describe what we observe in the nature.
Mm-hmm. Yeah, I think we have this perception from school, perhaps. It depends on how lucky you are to have how much engaging activities or lessons you had during the lessons. There is a perception that mathematics is very difficult. It's quite challenging. Is it so? Or what's the key to get into this research?
I think mathematics is similar science others, but I think it's a language, there's symbols, notation, which makes difficult. But the perception, natural truths, the law of nature, the same. That I think most difficult is syntax, language, the tools which created is too abstract, but it can be understood for any people. Also, I think it depends on teachers too, how they encourage, how they love mathematics. And I think there will be a lot of talents, but it depends on some circumstances and teachers, the people who meet in young age and or books which you read. Because there is a field medalist who was a writer when he's young age. He didn't like mathematics. But I think after bachelor degree, he started to interested in mathematics, and he's successful, and he won the field medals, which is similar like Nobel Prize, but only under 40 age for mathematicians.
Because we usually don't get to like just the name mathematics itself is intimidating. And so it's also interesting to know like what role does math play in one's everyday life and how to take advantage of it. Do you take advantage of it as a mathematician?
Well, maybe not too much as I want, but I use one theory when I want to make a decision and I'm under uncertainty, or I'm uncertain, then I use a large number theorem. This theorem tells that not to jump conclusion if you have a little information about situation, about anything. To get enough information, then it will be closer to truth, and then you can get conclusion. Simple example, I think everyone deals these days. If you are in the new city and you want to get some good restaurant, hotel, or something else, you start to look up reviews, right? And this review, you don't look only one review. You need to look up more than 10, hundreds maybe, or the stars that give us some impression in general. Because if you look up too little and only one review, it can be too negative or too good. And you cannot rely on one person. And for this one, I usually, and I think everyone does similar, that maybe it's not mathematics itself, but the principle behind it's the large number theorem. So if you want to be more advanced, you can add to this layer game theory that your decision will be depend also like action from other people too. Personally, I don't use it. I know this about this one. Maybe when I need this one, I can use, because as mathematician, we don't interact as much as other sciences maybe. I think we prefer to work or in small groups and work on boards. So we don't have this kind of interactions. But there is there is new prime minister of Romania.
Uh-huh.
He is trained as a mathematician.
Uh-huh.
He won school Olympiads 3 times, 3 golds.
Uh-huh.
Same time with the Trenstau, who is a kind of Mozart of mathematics now.
Uh-huh.
And he done his PhD in Paris.
Uh-huh.
And he done excellent job, but then he changed to the politics that he wants to contribute to society. Now he's prime minister, or he's president of Romania, actually. One of the good example. Also, second is I think like Cedric Villani, who he had a goal to become the mayor of the Paris. He went to the politics. I think he didn't succeed, but he showed that mathematicians can be good politicians too.
It would be interesting to see the Romanian president before he became a president and after he became a president. Also, the policy he made could be very interesting. How much it's calculated. Yeah.
Yes. Maybe he doesn't use mathematics, but he uses mathematical principles when he make a decision, analyze data.
Yeah, you also mentioned about that mathematicians are not that much social, and the first thing I think what I noticed entering this room is before, of course, equations a lot on the doors. I will also try to show as I speak, and a big whiteboard just behind me. Yeah, that shows actually how just gives the environment set up to strive for the mathematicians.
Yeah, I think we don't need a lot of stuff. For example, we need white paper, pencil, board, and imagination. That's all, I think.
Yeah. I guess it's also time to address the elephant in the room and AI. I guess it's a big thing globally.
Yes.
And some people are, of course, hopeful and that AI will bring more how to say it would be a powerful tool in their daily life. The others are scared, and there are also neutral people who, of course, withhold their opinion about AI. I'm one of them. I just try to balance the positive outcomes with negative outcomes, of course. So now I would like to ask you how AI is changing math domain.
Okay. Yeah, that's very interesting question again. And the artificial intelligence is developing with incredible speed. It's difficult to follow it, even news, how it's changing. Like every 2 months, they have new models, and every company has new models, and they have benchmarks. And one of them is reasoning and math reasoning. And they use mathematics, research mathematics as benchmark. It's OpenAI, Claude, or others trying to solve Erdos problems. There is mathematician Erdos who had a lot of thousands of problems, and it is put on the website, and any scientist, mathematician can look up and try to solve these problems with artificial intelligence. And now some of them is succeeding, and it's getting big news on the maybe the X or Twitter, and public start to think that maybe we don't need mathematicians. But that is false, because this interaction, it is iterative work with actual experts, mathematicians. Without them, they cannot solve big problems. But what I don't like that these companies use this benchmark and these problems to sell the products and making harm to the scientists, mathematicians, that the public and maybe governors or funders will start to wondering why we need mathematicians, right? That's concerning. But personally, I use, I think like artificial intelligence cannot replace expert mathematicians, but it can be very powerful collaborator. And also like it can accelerate your speed. It's, for example, if you have ideas, you can test already. You can compute yourself, then check the computation, your logical flaws. Also, when you finish your article, usually I used to do like put for 2 weeks, then I will try to find the typos, errors, logical flaws with fresh eyes. But now I can ask ChatGPT or Claude to look up the typos and make proofreading. That's changed a lot. And when you start to brainstorm to solve or to prove some terms, it's good for search of literature and connect with other domains, because mathematics is so broad now. the even like two so domains don't understand each other because they have different language, different syntax, maybe same thing but with different languages, which make difficult to interact. So that helps to translate to your domain language.
Just to mention here, actually, Terence Tao, who is one of the top mathematicians and field medalist in this domain, he also mentioned that AI is not a replacement for human mathematicians, but a powerful, tireless assistant, which is actually coincides with what you are saying at the moment. And I guess also to reflect, to balance here, I will try to play devil's advocate.
Yeah, of course.
I guess that most, I think what is concerning for academics is that, not to rely on it so much that they develop a brain rot, reverse evolution process where you just keep clicking the button and, don't give up all the critical thinking and just give all this to AI? Or what's your perspective on this?
Depends on person, maybe, is that how to use it. If you just use as everyday life, not doing yourself and relying on artificial intelligence, of course you stop thinking, you stop generating your proofs, ideas, then you just rely on that. That's always tempting, you want to, it's easy way because your brain won't minimize your energy, mental capacity. That's why he always want to just ask, don't spend a lot of energy.
Yes.
Just ask. But you need to yourself, stop and try to do yourself.
I guess that directly connects, and it's nice to see. First of all, thank you for sharing and giving your honest experience, because I think as academics we have to be more transparent and try to encourage our experience, because it's I think most people or most academics went through the same situation when the first models came out. Of course, some resisted, some did not, but then later on we learned all that the flaws of this using AI in academia. Apart from that, what you said directly links also with the interview we had prior with the Minister of Education in Kazakhstan and Science in Kazakhstan, Sayasat Nurbek, because he also says, if you know how to use AI, not for simple questions that you can ask from Google. Try to use it also in a more smarter way. Every request that it's filled in with questions to extract the best out of this powerful tool. So I guess that also correlates with what you're saying.
Yes, it's about your intention. How? If you want to improve yourself, then you use right way. Also now we have a seminar in our department that one of the professor, he used his Claude last a model which was banned now. He used this one to solve some problem in his field, and I think it is in logic. So what is good in our department that our professors share their experience with others, that how they work, and that is good thing.
Thank you for having us today again. And just on the perspective of today's event, signing the memorandum, I wanted to ask a few questions. Why education and science matters in Kazakhstan, and why it is essential to collaborate with Ghent University?
So Kazakhstan is the largest landlocked country in the world. And we're truly blessed with all kinds of resources, natural resources, a very diversified energy structure, energy framework, natural resources, critical minerals. We're number one uranium producer. About 43% of all the uranium produced in the world comes from Kazakhstan. But it is really the human capital, and more specifically, the quality of human capital that gives you that added value, that gives you that delta premium to make best out of your natural resources. I mean, you can be the richest country in the world in terms of natural resources, but you sell them at relatively low price. In order to create more sophisticated, more complex products and services, you really need human capital. That is why Kazakhstan has adopted new constitution declaring education, human capital, research and innovation top priorities of our country. That is why we're bringing a huge network of top research-intensive universities to the region, opening over 30 branch campuses with 40 solid research-intensive universities coming to Kazakhstan, opening their branch campuses. And now negotiating with Ghent University, being one of the leading research-intensive universities in Europe. And specifically, Ghent has a lot of research potential on biomedicine and many, many fields. But we chose this very specific field of math. So there's an excellent department of mathematics at Ghent University. And we are opening a mirror lab, just signed an MOU, because AI is one of the big priorities of Kazakhstan. And math is basically AI. AI is based on complex mathematical algorithms. And there's this really interesting intersectional link between, you need math to perfect AI, less hallucinations, more advanced solving algorithms, complex algorithms, but also AI perfects math. So AI for math is a big new thing. It helps to solve more complex problems. It helps to make math apparatus methodology more sophisticated, more complex. Because there are all kinds of new problems out there that man has to solve. There's astronomy, there's environment, there are more complex, quantum physics, you name it. So the core, the stepping stone of our partnership with Ghent University will be mirror lab with math and algorithmics and our AI National Center on AI Rastafta.
For young generation who will be listening to this interview as well, we have entered the era of digital era and AI, as well as global competition. And reflecting on that, of course, Kazakhstan has to sustain or remain its compatibility worldwide. What skills do you believe are essential for young generation?
Well, there are a few things I want to mention. One is creativity. The kind of a brute force solution of the problem solving is done by AI, now by AI, artificial intelligence, better than the humans. We have to admit it. There are all these assessments that prove that AI already surpassed the normal human being in thinking, in complex problem solving, and kind of this brute force, very systemic, methodological problem solving. But creativity is something very human. We can think in a very different ways, not mathematical ways, not this, framework. We can find this really ingenuous solution. So I do ask our young people, try to be more creative, think differently, find different ways of problem solving. Back in the day, design things. There are all kinds of new ways to teach you, to train you, or to think different. To emotional intelligence. There are certain things the machines cannot do. The emotional interaction with other human beings is that, the true human to human connection. That's what even the most complex machines are not able to do. So I think that's where we'll have that human moment. I think AI will actually emphasize, will actually point out, will strengthen what it means to be, the true human. It will hopefully will bring best in our nature. And third is problem solving, really. I mean, you can't reject AI, you can't deny AI, right? So if you harness the power of AI, if you learn how to use AI to solve problems, it can really help you to become that 10x employee. So back in the Silicon Valley, we understand that notion of 10x employee, someone who can do things better, faster than anyone else. So if you truly master, not just use AI, but you know how to use AI to help you solve problems, you truly become the 10x employee. I think that's the next big thing. So there'll be people who use AI improperly. They don't know how to really use AI. And there'll be people who know how to use AI properly to boost their productivity, to do complex problem solving, to find new solutions, to boost their creativity. So think of AI as a mirror. You give it a purpose, you give it your creativity, you give it your inner understanding of things, it will give you best it can. If you use it as a new Google, a more sophisticated Google, asking this, really mundane question, what is can we travel faster than the speed of light? It will just give you as a Google type of. So we need to learn, this new generation, our next generation, will be living in this AI world. So you need to learn to coexist with AI, co-learn with AI, co-create with AI. It's a great, powerful tool. You learn, you harness the power, you train your dragon, you'll be unbeatable.
So the last question I wanted to reflect, to summarize, what can Kazakh students learn from Ghent University and what Ghent University can learn from Kazakhstan?
Well, Ghent being a very great research university, research intensive university, I think that research culture is something that we lacked in our universities and we desperately trying to build. So most of our universities, unfortunately, are teaching universities. You go there and there's not much difference from school, right? From secondary high school. It's lectures, classes, books, assignment. And a lot of our students, they wonder, well, what do they still teach me, and they don't do much research. So we're trying to bring this new culture of research intensive university where you learn, but also you create, you do research. It's a work-based learning, research-based learning, project-based learning. There are all kinds of new ways to learn and do things. So this is, I think, what our students should learn from Ghent University, how to build this proper research culture in our universities.
I also want to know, because, as I said, just from the name, it's quite intimidating research domain. But what inspired you to do a research on this domain?
As bachelor's degree, I started doing mechanics in Kazakhstan, and it was celestial mechanics. Then I was interested in aerospace engineering, and I studied in US aerospace engineering in Georgia Tech. And then somehow I want to change to mathematics, pure mathematics. And I studied PhD in Kazakhstan, done, done some work on functional analysis, on some inequalities, but inside it was something was want to close to the space. Last 2 years now I'm working with partial differential equation motivated from the general relativity, which combines what was from my student master degrees interest to the mathematics. It somehow is emerged some point, some dots you cannot look back and connect these dots. It's as Steve Jobs told us. And so now I'm working as PDE on general relativity, how the waves propagates, how these models behave near the singularity, which singularity is big bangs, around the black holes, all this kind of stuff, which fascinating, very interesting. Maybe the physicist side, they understand why it works, but they don't have proofs. Mathematicians do logical proofs, which is, when mathematician prove one theorem, it's for all the time. Like 2000 years ago, the theorem was proved, it's same. It's not like someone can unprove it. That is the beauty of mathematics. So we are more try to prove logical ways.
Can we also reflect a bit on the history? Can you describe what role did math play in Soviet Union and also in Kazakhstan?
Okay.
And what is our history? How we are linked to mathematics in general?
Mathematics played important role in Soviet Union. And I believe that Soviet Union knew that they need people who can solve very complex problems and with critical thinking for the engineering, space missions, and technology. And they see people as a material, and they need very, very strong people. And they invested a lot of energy, money to create these best mathematical schools in Soviet Union. What they have done, they have a research institute at university, and it's linked to university, the high school, because they start to collect the talented pupils by Olympiads, and they promote to this specialized schools in mathematics and physics. And they create this kind of culture that mathematics is not just subject from high school. It's a way to think, to solve problem. It's nowadays we have this kind of still stereotype even in Kazakhstan that if you are good in mathematics, you will not die. You will have a job. It's like, and this way they created this culture. I think it was done by Kolmogorov, who had specialized schools. He trained these schools and collected all the students and promoted to Moscow University, Novosibirsk, and St. Petersburg. There was main three schools. It was St. Petersburg, Moscow, and Novosibirsk. And our Kazakh mathematicians trained in Novosibirsk school. That's why we have very strong partial differential equation specialist, functional analysis, and maybe also linear algebra. But I think like Kazakh mathematician lack of geometry, statisticians, and probability experts, which is maybe now is very important with this artificial intelligence. And nowadays, Kazakh mathematicians still have this good background from Soviet Union, but we have this kind of not problem. It's kind of gap between the young generation and old generation. It's around 20-25 years. That's actually a lot because of after Soviet Union collapsed, like most of the mathematicians, scientists left academia to find the jobs. So most of the young mathematicians in Kazakhstan is under 40, and the oldest, the youngest from the old generation is 60, 65. So, and we have more young generation, people who's under 40, who's have this culture from the Soviet Union, from our old generation, and we mixing, balancing with the European education, and we are in the more global Europe and US system. So we had a meeting with Sayasat Nurbek, Minister of Kazakhstan in Science and Higher Education, and we signed memorandum to open mirror lab of Ghent Analysis PDE Center in Kazakhstan, with collaboration with Institute of Mathematics and Mathematical Modeling, and based in Astana Hub in Alem AI. And this center mirror lab will focus on mathematics, fundamental mathematics, and mathematics behind artificial intelligence.
Okay, let me show the problem which I'm working. It's a wave recreation on the Kazakh space, on the Kazakh matrix, where you have G equal 1 up to 3, T to Lj, dxj square, U plus T minus 1, d1 dt U. This wave equation on Kazakh metric, which toy model of for Big Bang theory when we get close. Here Lj's, it will be L1, L2, L3. They are bigger than minus 1, and we want to understand asymptotics, how this when this time is approached to 0, how this wave propagates. The interesting stuff is that, like, here, since it's minus 1, when t approaches 0, these ones blow up, because 1 t will go to infinity as t goes to 0. 1 second, this side will go to 0. This, the Lj, go to 0 as, so we call it multiplicity. Two phenomena happen in same time at equal to 0. That wins this Big Bang. That this one will vanish, these ones blow up. And our goal is to understand how asymptotics of the solutions and how many loss of derivatives we will lose. And then when you put data, this asymptotic data to this initial data, to t equal to 0, and we want to scatter how propagates from the singular point to the other, and to find the that we try to find the Wilposens. What is the Wilposens of model? We want to prove that we have some model, that this model have existence. We prove existence of solution. First solution, right? We want to get, maybe that model doesn't have a solution. First we prove existence of solution. Second is that uniqueness, that maybe there are a lot of solutions, so we prove uniqueness. Then third, stability, is that, like, if we have initial data and we perturb a little bit, then the solution should perturb similar, shouldn't be go to different solution or different change very quickly. So if we satisfy and prove all this one, we have the Wilposens of this model. And why this is important? When and people from numerical, and this when they want to simulate these problems, they need to use this. If they don't have this theory, they cannot do this numerical analysis and simulation, because they cannot check themselves that when they solve numerical, is that this solution is converge, is it true or not? Maybe they're doing some model which doesn't have a solution, or they have a lot of solutions, so they can do simulation for. That's that it's kind of background for simulation and numerical analysis.
Is it your favorite equation?
Yes, wicked question. Yes. So another fact for mathematicians, we are conservative, so we still like to work on with chunks. And let me show one chunks, which is best tool for mathematician to think. And mathematicians call them Ferrari of the chunks. Actually, there is a movie about these chunks on Quantum magazine. I will share with you. So when you write, example, my favorite equation, it's so smooth. It's flow. Like it's perfect. I think it's like all the mathematicians, but when they heard that there is less chunks, they brought big chunk of the chunks for one room for all their lives. It's the best one, and I recommend to watch the movie about chunks.
I can share something from about space, since I have done the aerospace engineering and my master thesis about to find the trajectories to take a picture of 2 satellites of Mars for Phobos and Deimos. I'm from Kazakhstan and from Arkalyk, and the Arkalyk is a place where most of the space debris all land to Arkalyk nearby. And first, I think in Kazakhstan also landed in Arkalyk, and all the astronomers, all people come to the Arkalyk for 2 weeks and they wait when they will land. And I used to see this stuff. I think now I'm reflecting back, the connecting these dots and see that I think this interest come from this, that when I see this landings as because I know that when they land, they change weather to bad. But second, it was nice to see landing process, all this. Also, I have a teacher who saw how it lands.
I guess we have it in our DNA. I'm also an amateur astronomer. I have this deep curiosity, interest in space exploration studies. I guess we have it in our DNA.
Maybe, yeah. Also,
because it's
sky.
from Kazakh soil,
Yes.
right? Yeah.
Sky. When you look up to the sky in Kazakhstan, you can see everything.
A Milky Way. You can see Milky Way.
Yeah, because as nomads and I grew up in the small village.
Exactly, as nomads, it's in our DNA.
To see everything on the sky. Actually, I miss this kind of seeing the sky and all the stars.
Oh, same. I guess just to so that our listeners understand that we are both from Kazakhstan. I'm from South Kazakhstan, and
I'm Central Kazakhstan.
Yeah, and my city is actually a few kilometers away from Baikonur, and so therefore, and
your south part, I'm north part of Baikonur, so that's
Yes, exactly. And we have this, especially if you ever visit Kazakhstan, I will also try to put some photos on the screen. You can see Milky Way, and besides, we have this a family tradition to sleep outside during summer because it's too hot. And we always have this. I don't know if you had it the same way. We tell stories about the stars.
As a kid, I used to live in yurts with my grandfather, grandmother.
Yeah.
And now I think like we're so eco-friendly.
Exactly.
We change like every 2 months the place that like the grass should be, not stay in one place, to change every place. Season change, we change with season. That's incredible.
And I was also actually mentioning this a few episodes back. I think back in Sweden, we had this interview about circular economy, and I was just mentioning actually, if you really look back, the core of this, we already have it in Kazakhstan.
That's why sometimes I think like we get a lot of stuff from Soviet Union, but also we lost a lot of our DNA, all the survivor skills, and sometimes I want to get these skills back.
Yeah. To come back again, of course, when we talk, we just can't keep talking forever because we are both Kazakhs, first of all. Can you name your favorite mathematician or mathematicians, or any books you could recommend, or a movie you could rank that depicts the best life of a mathematician?
I think I will start with Henri Poincaré. So I think he's one of the few mathematicians who understood all mathematics. Also the Hilbert, but in Soviet Union there was a books called Biography of Great People, Жизнь прекрасных людей, and one of them was about Poincaré, and I get inspiration from this book. Also, like I read about three-body problem from his book, and he was trying to solve this problem. And as a student, I was trying to solve this problem. Because of that, I went to celestial mechanics also too. And he was also one of the people who understood what is chaos, dynamical system, and he made big step to the general relativity. Maybe he didn't have this Einstein equation, but he had all ideas already, and that Einstein could translate to formulas and put it in the right way. And one of the greatest mathematicians I appreciate is Henri Poincaré. Also, he put, like last 20th century, like all mathematician was working on Hilbert's problem. He proposed 23 problems, but Henri Poincaré told that all mathematicians will be focusing creating tools to understand quantum mechanics. And if we reflect back again, I think all the mathematicians was working to create tools for quantum mechanics, actually. And also, one of the favorite books is The Birth of Theorem by Cyril Villani. I can actually show this book. And it's very interesting. You can see even himself. He's field medalist. And why I like these books? The book. And he write his personal insight how he does mathematics, how he does proofs, how he struggles. Even this kind of smart people struggles, and how they overcome, and how they don't sleep and try to solve this problem. And also he put his email with colleagues to see how they interact. That's good insight. When I stack some problems and it's difficult or something, this kind of stuff, I read this book, get some inspiration, motivations. Also, it's very interesting person himself. Like what I like French mathematicians, that French appreciate mathematics as well as Soviet Union. Even they have a math museum. Also, for example, when you see Eiffel Tower, it's a symbol of love. But for me, It's symbol of science. There is a 75 name of the scientists on the when you read the names, and 24, 23 of them are mathematicians. And the one of the biggest nation who appreciate mathematics is the French people. And about movie, I think like the still best movie is A Beautiful Mind. I think the best actors.
That's also my favorite.
Yes,
Yeah.
I bought from Apple movies that when I'm tired from mathematics, I will just look up, watch this movie again.
It's based on true story.
Yes.
Mhm.
Sadly, he passed away a few years ago. And actually, he's won Nobel Prize. And everyone knows about his economics. But he was actually very best expert in his field, analysis and PDE. And then he done some stuff closes game theory. And he gets Nobel Prize. So you know that story about Nobel Prize and mathematicians that they don't like. Uh, I don't want to tell this story, but that mathematician not included in Nobel Prize. Maybe that's why we call ourselves artists than scientists.
That's a great way of expressing it. Mhm.
Yes,
Yeah.
but the mathematician gets a Nobel Prize in physics or in economics.
Mhm, mhm. Thank you very much, Bolys. Actually, it was quite engaging and interesting exchange and a talk. Before to close this episode, of course, traditionally we ask a few general questions, if you don't mind.
Mhm.
Yeah.
Yes, of course.
What skills do you believe are essential for incoming PhDs to develop on this domain?
Okay, let me tell that not my domain. Also rephrase that not incoming who's finishing PhD. That's most important, I think, because when PhD students come, there are a lot of advisors you can find everywhere. Also, you have a supervisor who taking care of you. But when you're finishing, analyzing, and going to the postdoc or industry, that's switching time from student to researcher. And my advice that when you're late of your PhDs, try to have own problems that not related to your supervisor, and try to change your direction of uh, PhD thesis, because when you try to get the job, they look up how you're independent. And to get also, you should know your field or also closer fields, and get not only with one method to try to understand other methods, go to the seminars which is not related to your fields to get ideas, to have some idea what's going on,
Or
not only mathematics, maybe even in physics, in social science,
Yeah.
maybe.
Or make a podcast with
Yes, with others. Yeah, that's I think like because that switching time, that's very important, and it's also a stressful time. Also, I think I recommend stay foolish, stay hungry.
Mhm, mhm.
That's what I say myself, and I try to say to young people too. It's not easy by age when you're getting your place, but staying hungry, it's not easy.
What would be your main message to the growing generation of scientists?
I think for new generation, I think they will be struggle with artificial intelligence. Use good intention to learn and improve yourself, and also use the books to check yourself in the artificial intelligence. I think nowadays books will be very important, classical books that you can compare what artificial intelligence saying and what you're learning. And I think there will be three ways: you, artificial intelligence, and the classical books. This triangle, That's, I think, most important for new generation.
Mhm. Thank you very much, Bolys. Thank you for having us.